Hello, good afternoon, everyone. I hope all of you are doing fine. Am I audible and visible to everyone? Good afternoon, Yarika. I hope things are fine at your end and everyone is doing nice. Well, to begin the class, Abhiram, good afternoon. I'll again begin with the same instructions. Keep your videos off so that you don't have this lagging problem. And if you have to send any message, do it on my ID with the name of Astik. Okay. With that, we should discuss the motion in two-dimension projectile that we were discussing in the last class. I think we had discussed about the time of flight. Let us go back and see what all things we had discussed. This is my x-axis. This is my y-axis. I've thrown the ball with an initial velocity u. It goes like this. It will end up here. Angle is theta. There are three terms that we must understand here. O is the point of projection. We call it as origin. It's the point from which you have thrown this ball. A and B. A is the point it reaches its maximum height. The vertical velocity at point A becomes 0. I think we have discussed this. The maximum height it attains is known as H max. Maximum height H max. And the distance it covers along the ground is known as the range of the projectile, represented by the letter R. I hope you all remember this. Then whatever time it takes to go from O to A and A to B, whatever time it takes to go from O to A and A to B, that time is known as the complete time it takes to go from O to A, time taken to go from O to A and A to B is known as time of flight, represented by capital T. Yes or no? We remember this? Time taken to go from O to A and from A to B is the total time of flight. Okay. Now, if that is the total time of flight, what will be the time taken to go from O to A? From the point of projection to the highest point in the trajectory, the highest point, if the total time is capital T, which is known as the time of flight, how much will be the time taken to go from O to A? It will be the time taken to go up, and that will be T divided by 2. Do we remember this? It will be half of the total time. Yes or no? Total time is time taken to go up plus time taken to come down. Both of them are same. And hence time taken to go up will be total time divided by 2. Now, on similar lines, if I call this middle point, this point as C, where it reaches its maximum height, if the total range is R, total distance on ground is R, what will be the distance from O to C? From O to C, if the total range, total distance is R, what will be the distance from O to C? Anyone? Yes, beta, definitely it will be equal to R by 2. Do we understand this? Can I have some raised hands? Total time of flight is capital T. Time taken to go from O to A will be half of that, T by 2. Total range, horizontal range from O to B, distance on ground is R. Therefore, distance from O to C will be equal to R by 2. Do you understand this? Can I have some raise hand? No one understands this? Yashwant, Tarun, Niharika, Jyoti, Surya, Tarun, Abhiram. Okay, we understand it that this will be equal to R. Okay, then we had seen the formula for time of flight. The formula for time of flight was 2u sine theta divided by g. That was one way of writing it. That was one way of writing it. The second way of writing it was 2 times uy. Uy is the vertical component of velocity divided by g. Do we remember these two forms? Do we remember these two forms? And then we had seen that this time of flight is directly proportional to, that this time of flight is directly proportional to u. If you increase the initial velocity, time of flight will increase. Time of flight is directly proportional to sine theta, or you can write theta. If the value of theta increases, the time of flight increases. This time of flight is inversely proportional to the acceleration due to gravity. On moon, the time of flight will become 6 times. Did we discuss this? Yes or no? Then time of flight depends on vertical component of velocity. It does not depend on horizontal component. If the vertical component remains same, the time of flight will remain same. Do we remember this? Can I have some raised hands? It's just based on what we have discussed from the formula T is equal to 2u sine theta by g. We have derived everything that I've written point wise, number 1 point, number 2 point, number 3 point, and number 4 point. We have written it on the basis of the formula T is equal to 2u sine theta by g. Can I have some raised hand that we understand this? No one has understood this? Okay. Now, let us, I had also given you a hint of what type of questions are asked. What type of questions are asked in JEE mains? Oh, sorry, in NEET. JEE mains was the last class. In NEET, regarding this, if you change velocity, what will happen to the time of flight? If you change angle, what will happen to the time of flight? Do we remember this? Okay, now there are some points which are given in your notes, which you can note down and remember. So instead of showing it on your notes, I will just show it here. So now if I have, let us say I will discuss this in this. Okay, I will make a different graph for this, different diagram. This is x-axis, this is y-axis, and I have thrown something at an angle of u, with a velocity u at an angle of theta. It goes like this and it comes down. Okay. Now, I might mark a point here, B, which is not on the highest point. It is somewhere in between. And the time it takes to go from A to B is T1. Time it takes to go from A to B is T1. And time it takes to go from here, let me call this point as O. Oh, instead of O, let me call it as A. Let me call this point as C. Time it takes to go from A to B is T1. Time it takes to go from B to C is T2. Can you tell me what will be T1 plus T2 equal to from this diagram? Important note. From A to B, the time taken is T1. From B to C, the time taken is T2. What will be T1 plus T2 equal to? What will be T1 plus T2 equal to? Anyone? What will be T1 plus T2 equal to? Yes, beta. Absolutely correct. T1 plus T2 will be equal to the total time of flight. Do we understand this? T1 plus T2 will be equal to the total time of flight. Do we understand this, everyone? Can I have some raised hand that we understand this, sir? Can I have some raised hand that we understand this? Everyone do understand this? Okay, so that is the first thing that you must remember about any general point B. With the time taken to go from the lowest point to point B is T1. Time taken to go from B again to the lowest point is T2. T1 plus T2 will always be equal to capital T, which is the time of flight. Now, let me call this height. Let me call the height from ground to B as h. I hope everyone can see this h. The height of point B is h. Now again, there is a small thing that you must remember about this point. It's very easy to derive it as well, but I will not go into the derivation part of it. You just have to remember this. And the thing that you need to remember this is the value of h. The value of h will be equal to g times T1, T2 divided by 2. Now that is the value that you must remember. That is the value that you must remember. There is no point of saying, sir, how do I achieve this? There is no use of that. The only thing is you will have very less time in the exam. And if you don't remember these small results, you will miss a lot of time. So you have to remember these two results about the time of flight from A to B, the total time is T1. From B to C, time is T2. T1 plus T2 will be equal to capital T. H will be equal to G into T1, T2 by 2. Or you can write this in this fashion. T1 multiplied by T2 is 2H by G. You can also remember it like this. You can remember equation number 2 like this. T1 into T2 is 2H by G. T1 into T2 is 2H by G. T1 plus T2 is capital T. Now this might remind you, that is equation number 1. This might remind you about something which is known as quadratic equation. Do you remember anything about this quadratic equation? You remember something known as quadratic equation. In this quadratic equation, we had sum of roots, and we had the multiplication of roots. So this formula has come from there, sum of roots and multiplication of roots. Sum of roots C1, T2, T1 plus T2 is capital T. Multiplication of roots is 2H by G. Am I clear? Do we understand this? Can I have some raised hand that we understand this, sir? Okay, so this formula has come from this. This is what you must remember about time of flight. What is total time of flight? 2u sine theta by g, or you can write it as 2 times uy by g. At any point, the time taken to go up is t1, time taken to come down is t2. T1 plus t2 is capital T. T1 multiplied by t2. T1 multiplied by t2 is 2 times h by g. Will you remember this? Will you remember this? Okay. Now, again, there is a small point that you must remember. I'm just making everything point wise, important point. Important point. Now, what is this important point? complementary angles. For complementary angles. You understand the meaning of complementary angles? You understand the meaning of complementary angles? You understand the meaning of complementary angles, anyone? See, if one time of flight T1 is 2u sine theta by g. Okay. Complementary angle means if one angle is theta, then the other angle would be how much? What is the sum of two complementary angles? If one angle is theta, the other angle would be 90 minus theta. Do we understand this? Sum of complementary angles is 90. So if one angle is theta, the other angle has to be 90 minus theta. Am I clear? Now, for angle theta, time of flight will be 2u sine theta by g. For angle 90 minus theta, what will be the time of flight? Let me call that as T2. So T2 will be 2 times u sine of 90 minus theta. Is everyone following me, or have I gone somewhere in space and I am lost there, lost in space? Do we understand this, what I am trying to do here? Do we understand this, what I am trying to do here? Okay. Sine of 90 minus theta is what? Sine of 90 minus theta is cos theta. So T2 becomes 2u cos theta by g. 2u cos theta by g. So I have T1 divided by T2. If I divide equation number 1 by equation number 2, what will I get? I will get the value of tan of theta. Am I clear? If I divide T1 by T2 for complementary angles, I will get the value of tan theta. Can I have some raised hand that we understand this, sir? Can I have some raised hand that we understand this, sir? Okay. Now there is one more formula that I can make here. T1 multiplied by T2. Now T1 multiplied by T2 will be 2u sine theta by g multiplied by 2u cos theta by g. So basically you can write it like this: 2 times divided by g times 2u square sine theta cos theta by g. I can write it like this. Now you would be wondering, sir, why you have written it like this? Why you have kept 2 by g outside, and why you have kept the rest of the things inside the bracket? Now there is a reason why I have done this, and by the end of this class, very soon, you will be able to understand why I have done this, why I have written or kept something inside the bracket and 2 by g outside the bracket. Do we understand up till this stage the different things that we must remember about the time of flight? Do we understand this? Raise of hands will give me more confidence that okay, we are on the same ground, we are on the same page. Yes or no? Now let us try to solve a problem, and the problem will be taken from your sheet, from your notes, and the problem comes right here on your screen. This is sample problems based on time of flight. Problem number 1 we'll be discussing after some time. Problem number 2, which is actually problem number 21, is what we are supposed to do to remember and understand the concept of time of flight. So the problem reads like this. A body is thrown with a velocity of 9.8 meter per second, making an angle of 30 degree with the horizontal. So initial velocity is given as 9.8 meter per second. Angle is 30 degree. It will hit the ground after how much time? So you throw it with a velocity 9.8 meter per second. After how much time will it hit the ground? Angle is given as 30 degrees. The question passes on to you. I am waiting for your answers. The question is pretty straightforward. Such are the questions you normally come in your NEET exam. Straightforward question, straightforward application of formula. You apply the formula and you will get your answers. Anyone got the answer? Time period. You have to calculate a time of flight. You simply apply the formula. Time is 2u sine theta by g. 2 is 2. Initial velocity is 9.8 meter per second. Multiplied by sine of 30. Angle of projection is 30. Divided by g. G की value is 9.8 meter per second square. In some questions, for simplicity, you can take this as 10. Here there is no need. So 9.8, 9.8 cancels out. Sine of 30, you must know, is half. So half multiplied by 2. The final answer will be 1 second. Everyone got this answer? Can I have some raised hands? Bashant, Tarun, are we there? Okay, we got this. Chalo. That was a simple question. These are the types of question that you can expect coming in the exam. Rest of the examples, example number 22 to 23, 24, they are not for you, so you can skip them. Problem number 26 is what is meant for you. So you must solve this problem. Problem number 26 is what you must solve now. A particle is thrown with a velocity u at an angle alpha with the horizontal. Another particle is thrown with the same velocity at an angle alpha with the vertical. One is thrown with an angle alpha with the horizontal. The other is thrown with an angle alpha with the vertical. What is the ratio of the time of flight? This question has come in your NEET exam 2018. A simple question, and I think you already know the answer. One angle is with the horizontal, alpha. The other angle is with the vertical, alpha. Can you get me the answer? Shall I do it or you can do it on your own? Shall I solve it? Okay, I hope everyone has read the question. Let us go about and solve it. So answer for question number 26, we'll make the two cases. This, let us say, is case number 1. X and Y particle thrown With a velocity u, the angle is alpha. Let us talk about this particle. Let us talk about this particle. What will be the time of flight for this particle? Let me call this as T1. What will be the time of flight for this particle? It will be 2u sine of alpha divided by g. Do we all agree on this? The time period for this would be 2u sine alpha divided by g. Simple application of formula. Yes or no? Do we understand this? Can I have some raised hands? X and y. Now for particle number 2, same velocity u, but this angle is alpha. Now, if the angle with the vertical is alpha, what will be this angle equal to? Angle with the horizontal, it becomes 90 minus alpha because the sum has to be equal to 90. Yes or no? Do we understand this? Great. Now let us calculate the time period of this, the time of flight of this particle. It will be 2u sine of 90 minus alpha divided by g. Now you must know what is the value of sine of 90 minus alpha. Do you know the value of sine of 90 minus alpha? We had seen this relation in our basic maths class. Sine of 90 minus alpha is how much? We also discussed it just now. Sine of 90 minus alpha is cos alpha. Do we understand this? Sine of 90 minus alpha is cos alpha. So your T2 becomes 2u cos of alpha divided by g. Your T2 becomes 2u cos alpha divided by g. Your T1 is 2u sin alpha divided by g. Now you can divide them and find the ratio T1 by T2. What will be the answer? T1 by T2, what will be the answer? Anyone? What will be the answer for this one? T1 by T2. How much is T1 by T2? Yes, Niharika, the answer will be T1 by T2 will be, oh, I've written tan of theta. I should have written tan of alpha, and that is our final answer. So as you can see, the questions are pretty damn simple. Do we understand this? Can I have raised hands? Can I have some raised hands? Okay. So this was everything that we had to discuss about the time of flight. 1 or 2 questions are left that we'll do, that you can do as homework. We have seen time of flight is 2u sine theta by g. We also wrote in the form of 2uy by g. It depends on the initial velocity. It depends on the sine of the angle. It is inversely proportional to g. It only depends on the vertical component. It does not depend on the horizontal component. Then we had seen if you take any point B in between anywhere, T1 plus T2 will be equal to capital T, and T1 multiplied by T2 will be 2h by g. They are actually roots of a quadratic equation. For complementary angles, we had seen T1 by T2 is tan theta, the same thing we did in the form of a question. We also saw T1 plus T2. T1 multiplied by T2 is 2 by g multiplied by 2u square sine theta cos theta by g. I also told you why we have written it in that fashion. By the end of this class, probably you will understand this. Okay, then we did questions. Now, let us discuss the second formula. Let us discuss the second formula. And the second formula is the formula of maximum height, H max. The formula of maximum height, H max. Anyone know this formula of H max? I would be very pleased if someone tells me the formula of H max. Anyone knows the formula of H max, maximum height? Has anyone gone through the notes that are there in your PDF? Yes, PDF handwritten notes. Anyone has gone through those notes? Can anyone tell me what is the formula of maximum height? Can anyone tell me? Niharika has written something else, very difficult for me to understand it. But I think she has written u square sine square theta something, right? U square sine square theta something. Anyone else would like to add u square sine square theta? I think that is correct. The numerator is correct. Can anyone tell me what's the denominator like? How much is the denominator? Can anyone tell me how much is the denominator? By 2g. Yes, u square sine square theta by 2g. I think is the answer. How many of you know it? How many of you know it? The formula for maximum height. The formula for maximum height. How many of you know it? Raise your hands, please, and tell me where have you seen this formula? Where have you seen this formula for maximum height? H max. The formula for H max is u square sine square theta by 2g. That is the formula. If you know this, very good. If you don't know this, remember it. Now again, I can write this in a different form. H max will be equal to uy squared divided by 2g. Why I've written it in this form? Why I've written it in this form? First of all, it makes things look easy, and then I can understand on what all factors it depends on. Now, as you can see, let us think about the understanding of this formula. H max is directly proportional to u ka squared, proportional to u squared. Time of flight is proportional to u. So if you make velocity twice, time of flight will become twice. But if you make velocity twice, what happens to the maximum height? How much times it becomes? If the velocity is made twice, what happens to the maximum height? Anyone? Yes, beta, it will become 4 times. Why it becomes 4 times? Because it becomes 2 square times. If you make the velocity 3 times, from 10 meter per second, you make the velocity 30 meter per second. What will happen to the maximum height? From 10 to 30, it has become 3 times. So the maximum height will become 3 multiplied by 3, 9 times. Am I clear? Am I clear? Yes, Niharika, it becomes 9 times. If you make the velocity 4 times, it becomes 16 times. If you make it 5 times, it becomes 25 times, and so on. The maximum height is directly proportional to u square. Is this point clear to everyone? Is this point clear to everyone? Very important point that you must remember. Okay. The next point is H max. H max is proportional to sine square theta. Proportional to sine square theta. That means again, if you make the angle from 30 to 60, it will increase in the square of that sine. Sine square 30, sine 30. For example, sine 30 is half, so sine square 30 becomes 1 by 4. Sine 60 is root 3 by 2. Sine square 60 will become 3 by 4. So now look at sine square 30 and look at sine square 40. Sorry, sine square 60. Look at sine square 30 and look at sine square 60. Is everyone looking there? Sine square 30, sine square 60. So, my question, if I make the angle twice from 30 to 60, from 30 to 60, velocity remaining same, magnitude remaining same, angle I have made 60 degrees from 30 degrees, how much time my maximum height will change? What will be the new value of maximum height? Anyone? From angle 30 to 60, if I make, how much times my maximum height becomes? Sine square 30 is 1 by 4, but sine square 60 is 3 by 4. So your maximum height becomes 3 times. Am I clear? Am I clear? Do we understand this? That my maximum height will become thrice. Okay. Similarly, this H max is inversely proportional to 1 by G. Remember, it's not proportional to 1 by G squared. This is the point where you will make a mistake because you will remember squared, U squared, sine squared. So you also think G squared. No, it's not proportional to or inversely proportional to G squared. It is only inversely proportional to G. So if you go to moon, your gravity, your acceleration due to gravity becomes 1 by 6 times, What happens to your maximum height? Your acceleration due to gravity on moon becomes 1 by 6 times. What happens to your maximum height? It will become 6 times. Your time of flight will also become 6 times. Your maximum height will also become 6 times. Am I clear with this? Okay, again, you must remember that H max depends on the vertical component of velocity. H max depends on the vertical component of velocity. H max does not depend on what? H max does not depend on the horizontal component of velocity. So even if you change your horizontal component, the maximum height does not change. Am I clear? Anyone has any doubts on this? Please come up. Else we will move. Anyone has any doubts on this? Please come up. Else I will move ahead. No one has any doubt? That is good. So I can move ahead. We will be solving questions on all the three after we are completed the third thing that we had to do. One was time of flight. Number 2 was maximum height. What was number 3? What was number 3? Range. Yes, Niharika. Number 3 was range. Some people also call it horizontal range. Number 3, range, or you can also call it horizontal range. Range or horizontal range, denoted by the legendary letter R. Now, horizontal range. Now, first of all, you have to understand and remember the formula for this horizontal range. Anyone can tell me the formula of this horizontal range? Anyone can tell me the formula of horizontal range? I would be very pleased and happy. Anyone tell me the formula of this horizontal range? Not expecting though. If you know it, I will be very happy. Okay. Range, horizontal range is 2 times u square sine theta cos theta by g. That is the formula I was looking for. 2 times u square sine square theta by g. This is the first way in which you can remember this. 2 times u square sine theta cos theta by g. Now, as soon as you see this, range is 2 times u square sine theta cos theta by g. Let us go back in time and see here. Do you see something here in yellow marked 2 times u square sine theta cos theta by g? This is actually equal to the range of the particle. Am I clear? This is equal to the range of the particle. Am I clear? Am I clear? So I can write this T1 multiplied by T2 is equal to 2 times R by G. And that is why I had written 2 by G outside. I had written 2 by G outside and I had written everything else inside. This is the formula of time of flights of complementary angles. T1 by T2 for complementary angles is tan of theta. T1 multiplied by T2 is 2 times R by G. Will you remember this? Will you remember this? So that is why it was written in this fashion. That is why it was written in this fashion. 2 times u square. What happened here? Where did it go? 2 times u square. Something happened here. What happened? Where did everything go? Vanished? Oops. What has happened here? Difficult to understand. Okay, it's here. Horizontal range is u 2 times u square sine theta cos theta by g. Everyone sees this? That T1, T2 is 2 times R by G. This is the first way of remembering this formula. Now, there is a simple formula in maths. You might not be aware of this, but there's a formula in maths where it says sine of 2 theta is 2 times sine theta into cos theta. Are we aware of this formula? Anyone is aware of this formula? Okay. For example, if I had to find sine of 60 degree, I can write this 60 degree. Oops. I can write this 60 degree. Oops. I can write this 60 degree as 2 multiplied by 30. So sine of 60 will nothing but, I can put this formula here, sine of 2 theta, 2 multiplied by 30. This will be equal to something is going on here. Okay, it will be equal to 2 times sine of 30 multiplied by cos of 30. Sine of 2 theta is 2 times sine theta into cos theta. So sine of 60 can be written as 2 times sine of 30 into cos of 30. If you put the values, you will get the same answer. So I can substitute this formula here. I see a 2. I see a sine theta cos theta. So instead of 2 times sine theta cos theta, how can I write this formula? I can write it as u squared sine 2 theta divided by g. We all agree on this? We all agree on this? Range can be written as u squared sine 2 theta divided by g. Can I have some raised hands? That's how we understand this. It is pretty simple, nothing else. We have just substituted the value of sine 2 theta. Now, once we get this value, I can write R as proportional to u squared. Range becomes proportional to u squared. That means if I make velocity twice, 2 times, what will happen to range? If I make velocity twice, what will happen to range? Anyone? What will happen to range if the velocity is made twice? What will happen to the range if the velocity is made twice? Yes, Niharika, range will become 4 times. If the velocity is made thrice, range will become 9 times. If the velocity is made 4 times, the range becomes 16 times. At the same time, range is proportional to sine of 2 theta. Remember, not sine of theta, but sine of 2 theta. Sine of 2 theta. So, if I increase the angle, the range will also increase if the value of sine 2 theta increases. Again, remember, range is inversely proportional to 1 by g. Sorry, inversely proportional to g. Again, if you go on moon, if on earth, you can throw a particle 10 meters in the range. For example, Kamalpreet Kaur in the discus throw, or today, Neeraj Kumar, I think, in javelin, he threw 88 meters on the horizontal ground range. How much he will be able to throw on moon? What will happen if you go to moon? If you can throw 10 meters here, how much you will be able to throw on moon with the same velocity and the same angle? Remember, acceleration due to gravity on moon is 6 times. And hence, if you can throw 10 meters here, you would be able to throw 60 meters on moon. Am I clear? Am I clear? So range is u squared sine 2 theta by g. So we have seen 2 different ways of writing range. This is number 1, R is 2u squared sine theta cos theta by g. Number 2 is range is u squared sine 2 theta by g. Don't need to panic. One and the same formula, just written in different ways. Okay, now you must be wondering, is there any other way of writing this? Is there any other way of writing this? Yes, there are. There are a few different ways of writing this. Way number 3. Way number 3. Range R is equal to Ux multiplied by T. What is T here? What is Ux here? What is T here? What is Ux here? Anyone? What is T? What is Ux? Ux is the horizontal component of velocity, which was u cos theta, and T is total time of flight. So range depends on both of the things. It also depends on time of flight. If the time of flight is more, range is more. It also depends on the horizontal velocity. If horizontal velocity is more, range is more. Am I clear? Am I clear? Way number 3. Raise hands will give me more confidence that things are getting clear in your head. Okay. Now, if you remember, time of flight was 2 times uy by g, 2 times uy by g. I can put this and I can get the last formula for range, 2 times ux uy by g. Do we all agree on this formula? Anyone has any doubt? This is the time that you raise up this doubt. This is the time that you raise up this doubt. Anyone has any doubt about this? 4 different ways of writing the range. 4 different ways of writing the range. Way number 1, 2u square sine theta cos theta by g. Way number 1. Way number 2, u square sine 2 theta by g. Tarika number 3, ux multiplied by t. Tarika number 4, 2 times ux into uy divided by g. Am I clear? Am I clear? Anyone have any doubts? Please raise your hands. Important point again. For complementary angles, again we did complementary angles in time of flight. For complementary angles, what do you mean by complementary angles? If one angle is theta, other angle becomes, if one angle becomes theta, other angle becomes 90 minus theta. Do we understand this? Do we understand this? Do we understand this? Now T1 becomes u square sine 2 theta by g. That becomes your time of flight for the angle theta. Your time of flight for the angle theta. Now what happens to the time of flight? What happens to the time of flight when you change the angle to 90 minus theta? Let us see T2. It will be u squared sine of 2 times 90 minus theta. Now, once you calculate this value, 2 times sine of 90 minus theta, it will become sine of 180 minus 2 theta. Sine of 180 minus 2 theta. And you must know that the value of sine of 180 minus 2 theta, why have written time of flight? I must write range. Sorry, beta. Genuine mistake. I must write range. Here also I must write range. Range for first case is u square sine 2 theta by g. Range for the second case is u square sine of 2 times 90 minus theta. 2 times 90 minus theta becomes sine 180 minus 2 theta. So My range second for the complementary angle becomes u square sine 2 theta by g. If you look at these two ranges for complementary angles, these two ranges for complementary angles, they are same. So we must remember for complementary angles, for complementary angles, for complementary angles, range is same. So you throw a ball at 30 degree with the same speed, you throw it at 60 degrees. In both the cases, the range would be same. Am I clear? Am I clear? If you throw something at 30 degree or you throw something at 60 degrees, in both cases, range will be same. In both cases, range will be same, provided that your angle, provided that your velocity is same. This is what it is shown in this note of yours. I hope you can see this note. If the angle of projection is C, in first case, there is a small tank which is trying to blast a submarine or a ship. In first case, the angle is 30 degrees. In second case, same velocity, but the angle is 60 degrees. For 60 degrees, it goes to a higher maximum height. For 30 degrees, it gets to a lower maximum height, but the range is same for both angles. One is 30 and another is 60. What is that you must remember about these two angles? These two angles are complementary angles. 30 plus 60 becomes 90. Can I have some raise of hands that we understand this, sir? For complementary angles, range will always remain same. But as you can see, when you change the angle, if you make the angle more, maximum height changes. Time of flight changes. As you can see, at 60 degree, it is getting more height. 30 degree, it was getting less height. The range, though, was same. In which case was the time of flight more? Look at that figure. Tell me in which case will the time of flight be more? In which case the maximum height is more? Tell me the answer fast. We're running out of time. 60 degree, Niharika, yes. For 60 degrees, the time of flight is more. For 60 degrees, maximum height is more. But for 30 and 60, at the same speed, I remind you, at the same speed, complementary angle, range remains same. Am I clear? Am I clear? Now there is one more thing that you must remember. There is one more thing that you must remember. Maximum range. Maximum range. Anyone have heard about this term? Maximum range. At what angle should you throw a ball or kick a football or strike a cricket ball so that it travels maximum? For maximum range, anyone, any idea? For maximum range, important point. Eyes on the sheet, important point. For maximum range. For maximum range. For a given velocity u, for a given velocity u, for a maximum range. Remember the formula for range is u squared sine of 2 theta by g. Now your u will remain constant. If I want to have maximum range, the value of sine 2 theta must be maximum. And the maximum value of sine 2 theta is 1. And it happens at theta key value 45. Because when theta key value is 45, sine of 2 times 45 becomes sine of 90. And you have maximum range. That means for maximum range, the angle of projection must be equal to what? For maximum range, the angle of projection must be equal to 45 degrees. Yes or no? Can I have some raised hands? For maximum range, the angle of projection must be 45 degree. And what will be the value of this maximum range? R max will be equal to, this thing will become 1. So it will become U squared by G, the maximum height. The maximum range will become U squared by G. That happens at an angle of, how much angle it happens? It happens at an angle of 45 degrees. So what we have learned in today's class, let us have a quick recap. What have we learned in today's class? We started with the time of flight. We went through the formula of time of flight. 2 times U sine theta by G, or 2 times Uy by G. We saw that the time of flight depends on U, it depends on sine theta, it is inversely proportional to G. It depends on the vertical component. Then we moved on to finding the time of flights for complementary angles. We also find out the time of flight for any point. The time taken to go up plus time taken to come down will be equal to total time of flight. The multiplication is 2 times h by g. We moved on to complementary angles. For complementary angles, time of flight, the ratio of time of flight is tan theta. The multiplication of time of flight is 2 times r by g. We moved on to maximum height. Maximum height is u square sine square theta by 2g. It depends on u square, it depends on sine square theta, it is inversely proportional to g. Then we went on and saw the formula for range. 4 different formulas. First is 2u square sine theta cos theta by g. Second is u square sine 2 theta by g. Third is ux multiplied by total time of flight. Fourth is 2 times ux uy by g. Then we saw for complementary angles, range remains same. I made a mistake. I was writing time. Maybe I was saying time as well. I don't know. I lost it somewhere. For maximum range, the value of theta must be 45 degrees and maximum range is u square by g. From the next class, in the next class, we'll begin from here. We'll be solving some questions on the sheet and probably we'll be winding up this part of the chapter, which was based on deriving the formula and doing some questions. If you have any doubts, you can ask me. I'll remain in the room. Else, it's a bye-bye from my side. I hope you remain safe, healthy, and remain happy. Bye-bye.